So today I'm going to be going over how to solve this equation to evaluate the limit algebraically. So in order to do that, we see that we have the limit as x approaches 5, x squared minus 5x all over x squared minus 4x minus 5. So there are multiple ways that we can approach this, but we can see, can we just plug 5 in? Can we just put 5 into where x is? So let's try that first. So that would be 0 over 0. Knowing that we can't just directly plug 5 into this, there's multiple ways we can rewrite the function to work in our favor in order to evaluate it. So a simple way is by taking out the factors of this top and bottom. So let's rewrite the limit as x approaches 5 all over. Both of these have x in them. So why don't we just bring it out? We bring it out to the front, and then we're left with x minus 5. For the bottom part, when factoring this out, you should get x plus 1 times x minus 5. There are many ways to factor this, but the way that I like to factor it out is by going back to what my teacher personally taught me, which was ABC, X method, and of course no one has to follow this. You guys can choose to do this if you would like to, but everyone has their own method of factoring. Now, going back to the equation, we see that both of these are the same, x minus 5 and x minus 5. And because these guys are just multiplying against each other, that gives us the chance to just cancel this out. That just becomes 1. We write the limit as x approaches 5. Now we're left with x over x plus 1. Remember, this is one piece together. Now that we have done that, it makes it easier. Maybe now we can plug in 5. So let's try that. Let's rewrite. So x approaches 5. So 5 on top and then 5 on the bottom. 5 plus 1. When we rewrite that, 2 5 equals 6. And that is our first answer to the limit approaching 5. For the next equation, we have limit as x approaches 3, 1 over x minus 1 over 3, all over x minus 3. So let's try directly plugging 3 into where x is and see if we can just get an answer like that. 0 over 0, indeterminate. In that case, we'll want to find a way to rewrite this equation. So I want to just write the limit as x approaches 3, 1x minus 1 over 3 all over x minus 3. What can we do about this equation to the point where we can plug x into here and not get 0 over 0? Well, we see that we have a fraction in our numerator. What we can do is multiply by the common denominator. In this case, the common denominator will be x and 3. So, parentheses around the whole equation, we'll do 3x, and then whatever you do on the top, you want to do on the bottom. So, when rewriting this, we multiply 3 into this, all over, and we're not going to do anything to the bottom to keep it simplified for now, and you'll see why later on. Now we're left with this. I'm going to go step by step. What can we do with this? We could have done it before, but we're going to do it now. Well, we see that we have x over x and we have 3 over 3. Those can cancel out. So when we're writing this, we should be left with 3 minus x all over x minus 3 times 3x. These look pretty similar. Maybe there's another way we can rewrite it. We can bring out the negative. So we'll have negative 1 of, this time x will be positive, but 3 will have to be negative. So when we work backwards, when we plug this in, we get negative x. Plug this in, we get a positive 3. Simple. We're just rewriting it, not changing much, but changing enough so that we can cancel out this part of the denominator. As you can tell, these two are the same. Cancel. And then rewrite this. So now we're just left with negative 1 over 3x. I think we can plug in 3 now into our equation, so let's do that. Negative 1 over 3 times 3, which is also equal to negative 1 over 9. And this will be our answer.